Okay, sequences. There are main two types of sequences which you're going to have to remember. You're also going to have to remember the words for all of the other kinds of sequences as well. The main two sequences which we do a lot of the analysis on are arithmetic sequences. Let's get back on there. Arithmetic and geometric. Okay, down a bit. Down there. Now, the things to remember for an arithmetic term, arithmetic sequence, is that the general term, okay, now in GCSE you called it the nth term, here we call it the kth term, okay? There's good reason for that, because we usually use the letter n to represent the last number in our sequence. But in core 2, the kth term, and we usually denote it by u, okay? And the kth term is going to be given by a plus k minus 1 lots of d. A is the first term, d is the common difference. An arithmetic sequence goes up in a constant amount. Okay. The second thing you need to remember and use is the sum of n terms of an arithmetic sequence, and that formula is half n. We've got big brackets, 2a plus n minus 1 d, close brackets. Okay? They're the two main formulas you need to remember for an arithmetic sequence. Geometric. Now UK, the rule for the kth term here is a, the first term, multiplied by r to the k minus 1. Okay, where r is the common ratio. The geometric sequences get multiplied by a constant amount. And here we have two formulas for the sum. We have the sum from 1 to n of the geometric sequence, which is a 1 minus r to the n all over 1 minus r. And we also have the sum to infinity, which is a over 1 minus r. But this is only true if the mod of r is less than 1. Now what this means is basically r is between 1 and minus 1. Okay, the common ratio is between 1 and minus 1. So these are all the things these are the formulas which you need to know to solve these sequences problems. When it comes to the questions in the exam, you're going to have to apply these formulas in many different ways. Okay? They're going to give you a bit of information, and you're going to have to decide which formula you're going to use to be able to solve that particular bit of information. Okay? So, right. The sequence. UK, okay, goes 4 x 36 108. Find the sum of the first 10 terms. Find the sum of the first 10 terms. Now, any ideas? Typical kind of Section A exam question here. It's not telling you whether it's geometric or arithmetic. Any ideas? How can we decide whether this is it arithmetic, this sequence? Actually, I should really put on another term here. Okay, this is not arithmetic. Why is it not arithmetic, Curtis? Why is it not arithmetic? That's the question. Yeah, go on.
Because it goes up by multiply ratio.
Yeah, we're multiplying a number here. We're not an arithmetic sequence is when the numbers go up in certain steps. Here they're not going up in steps. They're being multiplied. And what is the multiplier? 3. Okay? Because to get from 36 to 108, we times by 3. There we times by 3. Okay? So that means, what must x be? 12. X must be 12. Okay, and actually you didn't really need to worry about x because we've got all the information we need. So it's a geometric sequence. A, the first term is 4, the common ratio is 3. So the sum, the first 10 terms, sum from 1 to 10 of this sequence, UK, is going to be equal to, we're using the formula, which is A, 1 minus r to the n, 1 minus r, it's going to be equal to 4 multiplied by 1 minus 3 to the power of n, divided by 1 minus 3. And n in this case, sorry, would be to the power of 10. This is going to be a massive number. So 4 multiplied by 1 minus 3 to the power of 10 divided by minus 2 is 118096. 11896. Okay. Okay, so that's a geometric problem. Now, do an arithmetic problem, shall we? Do an arithmetic problem. Right. An arithmetic sequence has. Alright, let's have a look here. Has 30 terms in it. Okay, so 30 terms. What's that? What is 30 then, in terms of all our letters which we have? What does 30 represent? Which letter does 30 represent? N. This is the number of terms there are. So we instantly know that n is 30. Okay? Right. The first term is 4. The sum of the 30 terms is, I'm just making this question up on this card. I'm just going to quickly do some calculations. Okay, it's 204. Find the common difference. Common difference. So we've got a sequence which is going up by the same amount of time. It starts at 4. We don't know how much it's going up by, but we know if we've got 30 of the terms and we add them up, we get 204. Now that's enough information to work out what our common difference is. Now, if we go back to the original formulas, which formula are we going to use? Are we going to use 1, 2, 3, 4, or 5?
2.
Why 2?
The
I gave you some information in the question which said the sum of all of these terms was 204. So we're going to use this. It's arithmetic, so we're going to have to use this formula. Okay? So, the sum of n terms of a arithmetic sequence is half n 2 lots of A plus n minus 1 lots of D. Okay, that's the formula. I'm now going to have to put all the information from the question into my formula, and I'm going to have to solve an equation. So, we know here that n is 30, and we know that A is equal to 4 from here, and we also know that the sum is equal to 204. So first of all, we know that this is going to be 204, the left-hand side is 204. We're going to have half n is 30, multiplied by 2 lots of A, which is 2 lots of 4, plus n minus 1 lots of D, so that's 30 minus 1 lots of D. Okay. Now notice here we've got one unknown. D is the only thing we don't know. All the rest is numbers. We're going to have a nice little equation to solve here. So, first of all, how I would solve this, well, let's do all the calculations to make this look nicer. Half of 30 is 15. Okay. And we have 8 plus 29D. Okay. There's our little equation. I don't think we need the big square brackets now. We can just do these as to make it look a little bit nicer. Right, we've got to solve this equation. Simple linear equation. What would you do first? Lewis? You could multiply it out by the brackets, but what would be a quicker way? Let's just divide by the 15. Okay. So divided by 15, 204 divided by 15 is 13.6 is equal to 8 plus 29D. Okay. Now we need to find D. What do we do? Yes. Take away 8. This is a standard equation. 13.6 take away 8 is 5.6. So that's equal to 29D. And finally, what's D? Well, we find that out by dividing by 29. So D is equal to 5.6 divided by 29. That doesn't look too nice, so we'll write that as 28 over 145. You then say to yourself, crikey, that's a weird answer. I must have done wrong. The answer isn't like a nice little positive whole number. Okay? Don't be a little number hater. Okay? This is just as good a number as minus 1. If not better, there's more digits. It looks more different, doesn't it? We don't like boring minus 1s, or 1s, or 2s. Okay? Also, I made this question up just like that, so we're quite rare to expect a good answer. I did my calculations wrong to expect a good answer. But we've proven the maths that has to be the right answer. So sequences questions, they're all about, you're going to get information from the question, you've got to put them into one of the formulas, and you're going to have to solve an equation. Okay? You could get something completely non-related to arithmetic sequences and geometric sequences. You could get a random one. You know, UK is k squared minus 4. Okay, section A question. Find the first 3 terms. How do we do this? Find the first 3 terms of this sequence. Louis. You just put in 1, 2, and 3, and we get our first 3 terms. So U1 is going to be 1 squared minus 4, which is minus 3. U2, 2 squared minus 4, which is 0. U3, 3 squared minus 4, which is 5. Okay? This is actually an example of a quadratic sequence. Okay, but you don't need to necessarily know that. You could get an even different one. You could get UK plus 1 is equal to 5 plus UK, and U1 is equal to 2. Here's a different way they could ask you to find a sequence. Find first 3 terms. How do we find the first 3 terms of this one? Louis? Yeah.
Would you like to put in UK is would be whether U1 is
Yeah, this one's slightly different because to get the next term, we have to rely on the previous term, UK. To get the UK plus 1th term, we have to get the kth term. Okay? This one here purely just relied on k. It didn't rely on what from here, this one here, we could straight away work out the 100th term just like that. The 100th term would be 100 squared minus 4, which would be 10,000 minus 4, 9,996. We know that straight away. The only way we can get the 100th term for this sequence is if we find the 99th term. The only way we can get the 99th term is to get the 98th term, and so on and so forth. Okay? So if U1 is 2, U2 is 5 plus 2, which is 7. U3 is going to be 5 plus U2, 5 plus 7 is 12. Okay?